Okay, so let's look at question 1. There are very few accidental causes of arson which make it easy for an investigator to determine the cause of a fire. Well, because there are a lot of accidental cases as far as fires being set, it makes it hard for an investigator to determine the cause of a fire. So when they come to examine the scene of a fire, there's a lot of different factors that they've got to go through and look at before they can actually determine was it an accident or not. So this one was false. Question 2, the two things necessary to maintain a fire are a fuel source and a carbon dioxide source. Well, here in fuel source, that is one thing, but carbon dioxide is not what's needed. You need a source of oxygen. So F, or should have been answer choice B for false. Question 3, fires don't always have the same rate of reaction. Gas fuel fires will burn faster than solid fuel fires. Well, that one is true, and that's because the state of matter that the fuel is in will burn quicker if it's in a gas, where solid is not going to burn as quickly. It's going to take a long time for that reaction or that fire to start. Same thing, if I were to set gasoline on fire, that's going to burn very quickly, whereas if I set like firewood on fire, it would take a while for that fire to kind of get burning and going. Question 4, many fires, especially in buildings with lots of metals, will spread via conduction through beams, nails, and bolts. We talked about that in our key points review. Conduction is that direct contact. So the fire is going to spread, and that heat is going to spread through beams, nails, and bolts because those things are metal. They're good conductors of heat. So that one is true. And then our last one of the most important pieces of evidence that needs to be collected is any unburned accelerants that may still be present at the scene of the crime. Well, if we're at a scene of a fire, we're going to investigate was this fire set deliberately. Well, accelerants or presence of an accelerant is going to tell maybe that fire was set on purpose. And so if there are any unburned accelerants at the scene of the fire, that's one of the main pieces of evidence that I'm going to want to collect. So that one is also true. Okay, multiple choice section. Number 6, a search of a fire scene must focus on, first, and kind of the main point is we're always going to look for the fire's origin, or where did it start. So C is going to be something that I want to do first, and that's my whole investigation is going to focus on that point. Yes, I am going to collect trace evidence, ascertaining whether an actual crime has been committed. Yes, I'm going to look at that. Was it arson or was this an accident? And then estimating the monetary value of loss, that's going to be more of like an insurance claim. The main focus of an arson investigation is actually finding where that fire started. Question 7, all of the following are used to locate the fire's origin except, so A, the lowest point with most intense burning. That is going to tell where that fire started, because this one has the most intense burning because it's going to be the place that's been burning the longest. So, and we know that fires start from low and then move to a higher place, which is going to help us or show us this V-shaped pattern as well. So this one and this one are two ways to find the fire's origin. And then through that, there's going to give us maybe an irregularly shaped burn pattern. So we might have, if gasoline's been poured, we're going to see a type of burn pattern maybe that will exist, like streamers and things that we talked about in our crime scene investigations or our case studies. And so that one is as well. A high concentration of CO2 in the air is not going to really help us locate a fire's origin. So B is our answer. 8. All of the following are correct statements on collecting and preserving fire evidence except, so use polyethylene bags for clothing only and airtight containers for bulkier objects. Well, polyethylene bags are basically like a plastic type bag, and so we know, and we talked about it numerous of times, that we always want our stuff in airtight containers. So A is probably not the right answer. B, use airtight containers to prevent residues from evaporating. That is true. That's a process that we want to do. If found within a few hours, collect the suspect's clothing in an airtight container. Yes, and then obtain a substrate control to ensure proper and accurate analytical results. Anytime we collect evidence, we're always going to want to find a substrate control, and we talked about that in numerous of our case studies examples. So the answer for 8 is choice A. 9. Arson investigators must work quickly to collect evidence at a fire scene because accelerants evaporate within several hours of the fire. Well, that's true. Accelerants are going to evaporate, especially if they're like petroleum based, and so we've got to work quickly, and that's one reason for it. Safety conditions may keep investigators from searching immediately after a fire is out. Yes, because of it being a fire and things still burning and being hot and ash and things like that, there might be a few days that investigators not able to get to the scene. So as soon as it's safe to do so, that fire scene needs to be investigated immediately. And then bacteria in soil can degrade accelerants left from the fire. That's true. That bacteria is going to eat at or degrade those accelerants, which is then going to make it hard to find that accelerant, which could be a key piece of evidence in finding either the fire's point of origin, or also finding if the fire was set deliberately or not. So that one's true. So your answer is D, all of the above. Okay, question 10. Finding the origin of a fire can be misleading because fires can deviate from their normal behavior due to all of the following except. So in our key points of study, I know that we hit on talking about how there are different things that can cause fire to act erratically. And so it's going to be able to, or kind of make it hard for an investigator to find where that point of origin is located. So A, airflow patterns or currents move fire from room to room, making the origin difficult to determine. So different airflow patterns or drafts or different strong winds outside is all going to affect it. So that one is true. Collapsing floors and roof create secondary fires. That is true. And then the presence of stairways and elevators move fires unexpectedly. So anything to do with like the layout of the building, especially stairways and elevators, are going to move those fires kind of unexpectedly in a random way. And so that one's true. Accelerants are burned completely in very intense fires, leaving no trace evidence. Well, that's not a true statement because accelerants can be left behind. They can be soaked up by different items, and so those accelerants can be found even in an intense fire, as long as those investigators work quickly. So that is not one. So D would be the correct answer for this question. 11, the single most important step in the detection and analysis of explosive residue is, so we're talking about explosive residue here, so chapter 15, concepts. First thing is that I'm always going to want to collect appropriate samples. So I'm going to want to gather that evidence, gather anything that's been left behind, and try to determine, what type of explosives were used. Is there any type of residue left? So C would be your correct answer. Terrorist group or individual responsible for the blast, that's going to be more of like, FBI investigators, CIA, things like that. So that one's not logical. Locating the ignition switch and maintaining a chain of custody, those things are important, but it's not the most important step. It's not kind of the main reason that you're out there. So we're looking for the most. So that one would not be it. And then determination of whether it was a high or low explosive with use. Well, I can't even determine that until I actually collect samples of explosive residue that's left behind to determine what type of explosive was used. So that would not be correct either. 12. All high explosive bombs or weapons are detonated in a series of steps. Which of the following is a correct sequence of events that detonates an explosive? Well, this is one that we talked about in our explosives key points of the steps of that high explosive. So first off, a primary, or really I've got to have something that's going to ignite the explosive. So I'm going to have a fuse, so some type of fuse, or some type of an electrical charge. So that could come from like cell phones, timers, detonation switches. There's a lot of different things, and you've probably even seen it like in action movies of that being depicted. So this would be my first step here. The second step is that some type of primary explosive is going to detonate before I can actually detonate the high explosive or the secondary explosive, because we're dealing with a high explosive here. Okay, so the first thing after the safety fuse burns, it's going to detonate a blasting cap, which is a primary explosive. And then that's going to cause that violent expansion of gas and heat, which is then going to provide the energy necessary for the booster to detonate and go off. And then my last step is that the main charge is going to be ignited and explode. Okay, so my answer choice here should have been 4, 2, 1, and 3. So answer choice C for number 12. Question 13. All of the following are correct protocol for collecting and preserving explosive evidence except. So we're looking for the odd one out here. So wear gloves, shoe covers, coveralls, make sure that there's no contamination. That's just proper safety. So that one is good. So I would definitely want to do that. Collect only porous materials such as wood and soil. Non-porous materials do not absorb accelerants and are not useful. Well, if it's non-porous, it might not absorb, but those accelerants could be left on it, so I could still find them. And saying that non-porous materials are not useful is just, it's not true. You're going to collect porous and non-porous materials, whether they're going to absorb accelerants or not. So that one is definitely not proper protocol. So that one is going to be our answer. And then I'm going to look at the other ones just to check. Collect all evidence in airtight containers to prevent evaporation. Again, we talked about airtight containers. That's proper protocol, so that one's true. And then D, all loose soil and debris should be removed and preserved immediately. Freeze to prevent bacterial degradation. So we talked about in one of the earlier questions where bacteria is actually going to degrade some of the accelerants that might be present. So I'm going to actually freeze the debris so that it stops that process or slows that process down. So that is proper procedure as well. So answer choice B. Question 14. What is the first procedure typically used to analyze bomb scene debris that arrives in the laboratory? So we talked about that specifically in our key points review over chapter 15. And so after I collect all this evidence at the scene of the crime, the very first step of the first procedure that's going to happen is that the examiner is going to do a microscopic examination and kind of begin to look at that stuff through the microscope. 15, technique that is used to identify compounds used to start a fire. That's really just a definition. Again, we went over in our key points review. It is on your Quizlet flashcards, and that's just gas chromatography. That's the process of I'm looking at the compounds that are used to start a fire, and that's going to lead me in my investigation further to know what possibly caused the fire to start. Question 16, the rapid combination of oxygen with fuel, which produces a noticeable release of energy, is called. Well, again, this was a key term definition. This was also talked about in your key points review and on the Quizlet flashcards. And so when I get this rapid combination of oxygen with fuel, we know that those two things are needed to start a fire. And then if I have a production of noticeable energy release, that is letter choice D for combustion.